Hello, everyone. I'm Frank, and welcome to Learn How to Sudoku, episode 12. And this is where we take a very easy puzzle and we try to break it down as much as possible so that it makes it easy for people to understand the logic behind it so that they can actually apply this to more Sudoku puzzles in their lives. Anyways, today's puzzle is a very easy puzzle called Integral of X Squared by Evan. And we actually did one of these before. It was the integral of x cubed. And I didn't actually notice, but that the actual integral actually did sum to the cages that added up to, that was underneath the actual curve. And I'm expecting something similar because he did a really good job with that previously. So this is sort of in the shape of an x squared parabola. Obviously, it's not going to be exactly like x squared parabola would look like, but it's a pretty good approximation. And I'm assuming that these sums add up to essentially the actual integral of x squared. Anyways, on to the rules. Renban lines. Pink lines must contain a set of consecutive digits in any order without repeats. So, and basically this is one Renban line, this is one Renban line, and this is a Renban line, and this is a separate Renban line. Because the x's is basically just two lines crossed. And they must contain a set of consecutive digits in any order. So, for example, if this had a 1 on it, you would know that there would have to be a 2, 3, a 4, and a 5 somewhere else on the line, because the only set that 1 is a consecutive set of that has 5 digits is 1 through 5. So therefore, if you have a 1, you know therefore the rest of the digits must be, again, 2, 3, 4, and 5. So that's how Renban line works. Region sum lines. Digits on a blue line have an equal sum n within each box it passes through. So for example, these 3 digits must be the same, must sum up to the same value as these 3 digits, which must sum up to the same value as these 3 digits, because that's how region sum lines work, right? Where the digits on the blue line have equal sum n within each box it passes through. German whisper lines. 2 cells connected by a green line, which is these 2 and then these 2, must have a difference of at least 5. So for example, if this were a 3, this would have to be an 8 or a 9 to satisfy the German whisper line rule, because there has to be a difference of at least 5 between adjacent digits on a German whisper line. Killer cages. Digits in cages must sum to the number in the top left corner and cannot repeat. That's not important in this puzzle, but in other puzzles that might be. Anyways, that just means that these 2 digits must add up to 11, these 2 must add up to 13, these must add up to 13, these 3 digits must add up to 19, etc., etc. So an example of this would be 2 and 5, because the 2 plus the 5 add up to 7. And that's how killer cages work. XV. Cells joined by an X or a V must sum to a 10 for an X or 5 for a V. So these 2 digits must add up to 10, and these 2 digits must add up to 5, these 2 digits must add up to 10, etc., etc. And an example for these would be 2 and 8, and if this were 2, this would have to be 3 to add up to 5, and these 2 add up to 10. And those are all the rules. If you like to play, and there's a note, the minus sign to the left of the 4 in row 3, column 2, is purely cosmetic. Well, it's not completely cosmetic. It allows us to get the actual integral from one of the endpoints for the integral. But other than that, it has no relationship to the actual puzzle itself. Anyways, if you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, so obviously the simple one to start with is the cage of 1, which has to be 1 because the digits must sum up to 1. We also know that if you ever have 2 digits that add up to 4, it can only be the possibility of, and they're unique, it can only be the possibility of 1 and 3, right? So because there's a 1-3 pair there cannot be a 1 or 3 in the rest of the column. So therefore, the 7 cannot contain a 1 or 3 either. This 7 cage cannot contain a 1 or 3. So it must be either 1-6, 2-5, or 3-4. Obviously, 1 and 6 are eliminated because of the 1 can't be there, and 3-4 is eliminated because the 3 can't be there. Therefore, this must be 2 and 5. Now, this cell plus another cell adds up to 5. The only digits that can work there then are 1, 2, 3, and 4. But we have a 1-3 pair and we have a 2-5 pair, which means that neither of these pairs can be 1, 2, 3, or 5. Sorry, none of these digits in this cell can be 1, 2, 3, or 5. Therefore, the only possibility now can be has to be 4, which adds up with 1 to make 5. Therefore, this cage now becomes 1 and 6 because 1 and 6 add up to 7. Because of the 2-5 pair and the 1-3 pair in column 7, the rest of the column must now be 6, 7, 8, or 9. Now, for this Renban, okay, so this can't be 8. For this Renban, okay, so in addition, this can't be 6. So we know where is the 6. The 6 has to be on this Renban line in column 7. So we know the 6 and at least the 7 and 8 have to be on this Renban line. Well, what number of 5 consecutive digits works that has 6, 7, and or 8 or 9? Well, it has to be either 4, excuse me, 4 through 8, or it's 5 through 9. So this is either 4 through 8, which means this would be 4, because the 4 limit is eliminated here, and that would be 5. But one of these has to be 5, we know, because we know it has to have 5 at least. And this has a 6, so it cannot be 6. It could be 7, 8, or 9, though. So we know 5 has to be there because of the Renban containing 4, 5, 6, 7, 8, or 5, 6, 7, 8, and 9. And 5 is not along this Renban, this line, so it must be here. In addition, let's see. This 3-cell cage, excuse me, that adds up to 12, it cannot have a 1. So the possibilities are only 2, 4, and 6, 2, 3, and 7, or 3, 4, and 5. This cannot be 5 and 6, and it cannot be 4 and 7. So this is 2 and 9, or it's 3 and 8. We're not sure which. This must be 4, 9, 5, 8, or 6, 7. So this can't be 6, which means this can't be 7. Similarly, this is also 4, 9, 5, 8, or 6, 7. So we know we have 1 digit here from 8 and 9. 1 digit here is from 7, 8, or 9. And 1 digit here is from 7, 8, or 9. Therefore, none of these digits can be from 7, 8, or 9. So it could be 1 through 6 then. Because we have 3 digits from 7, 8, or 9 here already. Therefore, there cannot be a 7, 8, or 9 in the rest of the column. This can't be 4, so therefore this can't be 9. Let's see, what else do we have here? This cannot contain a 6. Oh, right. This can't be 6 because we know the 6 has to be here in column 7, though. So one of these three is a 6, and therefore one of them is a 7, but we already knew that, though. So let's see. This can't be 4. Since this can't be 4, that means this cannot be 5 to be on a Renban with it. And it can't be 6. You can have 1 through 6 technically for these two, but 1 and 6 cannot be there. Therefore, this could be 2, 3, 4, 5. But this can't be 4. Neither of these could be 4, so then neither of these could be 5, because if they were on a Renban, they would have to be next to a 4 or a 6, and the 6 we know is already over here. So these cannot be 5. Therefore, we have 5 digits in box 3, 5 cells, shall we say, in box 3 that contain the digits 1 through 5. Therefore, the other cells in the box cannot contain a 1 through 5. Therefore, this has to be also 6, 7, or 9. So now we know where is the 8 in box 3. Can't be here, can't be any of these. It must be one of these two, which eliminates the 8 from this cell. Okay. This can't be 6 again. So this is either 7 or 9, and this is 7 or 9. Now, we have 3 digits adding up to 19. Actually, let's go use this one. In box 7, we have 3 cages which contain 7 digits, and they must add up to 22 plus 12. Sorry, 20 plus 12, which is 32. Therefore, these 2 digits must add up to 13, right? Because in the box you have all the digits add up to 45, and these 7 digits in particular add up to 32, sorry. Not 22, 32. And 45 minus 32 is 13, so therefore these 2 cells add up to 13. Now, these 2 cells can only be from 1 through 6, right? Because they add up to 7. So this has to be 1 through 6, 2, 3, 4, 5, 6. This can't be 1, though. This can't be 6. That works fine. But we know these 2 cells add up to 13. And the minimum you can have on a digit in one of those cells would be a 4, because you have 4 with 9 adding up to 13. So this would have to be at least 4, which means this can't be, this is at most 3. So this is 4, 5, or 6, and it goes with 7, 8, or 9. Because 4 adds up with 9 to 13, 5 with 8 adds up to 13, and 6 with 7 adds up to 13. Therefore, to add up to 15 for these 2 digits, it must be 6, 7, or 8. To add up with 6, 9, 7, 8, and 7, 8, 7. But this can't be 6 because we know there's a 6 here. So therefore, this can't be 9. Which means this can no longer be 4, and this can no longer be 3. So we know 7 and 8 are, we have a 7-8 pair in this cage. Well, that eliminates 1 8 from this 9 cage and 2 7 from this 9 cage. So this is either 3 6 or 4 5. And we know these 2 digits add up to 5, so they have to be 4 at most. So this is 3 4, this is 5 or 6. Now we have a 5 6 5 6 pair in box 7. And we call this box 7 because we count the boxes, we number the boxes, it's kind of arbitrarily, from left to right, and then from top to bottom. So this is box 1, this is box 2, this is box 3, this is 4, 5, 6, and therefore this must be box 7. So therefore, we have a 5 6 5 6 pair in box 7, so the rest of the cells in the box cannot contain a 5 or a 6. So this cannot be 5 or 6. This cannot contain 5 or 6. We also know where is the 1. The 1 cannot be any of these cells. It can't be in the 9 cell, and it can't be in the 11 cell because 1 added up with no other digit can add up to 11. 1 can add up to 11 with a 10, but that's not a digit, obviously. So the 1 has to be here. So it's either 1 with 2, 9, 3, 8, or 4, 7. It cannot be 4 and 7, and it cannot be 3, 8, because we have a 4 and 8 in the same column. Therefore, this must be 1, 2, and 9. Which means this can't be 9. This is either 3, 8, or it's 4, 7. Because this adds up to 11. Now we have a 1, 2, 9 triplet in column 2, which eliminates 1, 2, and 9 from the rest of the column. Therefore, this killer cage of 8 would only have had the possibilities of 1, 7, 2, 6, and 3, 5. Well, it cannot be 1 or 2 because those are eliminated, so that must be 3 and 5. Which means that the rest of the column must contain a 6 and a 7 because those are the only ones left. So this is 6 and 7. Also, on this Renban line, we already have a 4 and an 8 here. What are the rest of the digits? It has to be 5, 6, and 7 because that's the only way you form a continuous set of digits. Right? Because 4 can only be with 5, 6, 7, 8 to add up to have it be continuous with 8. And that's 5 digits already. So this can't be, this is 5, 6, or 7. This is 5, 6, or 7, which means we have a 5, 6, 7 triplet in box 1. So the rest of the box cannot contain 5, 6, and 7, along with 4 and 8. So this must be 1, 2, 3, or 9. And this is 1, 2, 3, or 9. Now, these two digits add up to 10. We have a 3, 5, 3, 5 pair in box 4, so the rest of box 4 cannot contain a 3 or 5. Therefore, this can't be 3, which would have to add up with 7 to add up to 10. Therefore, that makes this a 6, and this is a 4. Now, this 11 cage, killer cage, can only be 2, 9, 3, 8, 4, 7, or 5, 6. Well, the 6 is eliminated because of that 6 in the box. The 4 is eliminated because of the 4 in the box, and the 3 is eliminated because of the 3 in the box. Therefore, this must be 2 and 9. Which means 2 and 9 cannot be here. So now we have a 1, 3, 1, 3 pair, both in box 1 and in column 1. So that means 1, 3 cannot be in the cells in the rest of the cells in box 1, and cannot be in the rest of the column of column 1. So these can't be 1 or 3, so it must be 2 or 9. This can't be 3, so it makes that 4. And 4 has to be with 5 to add up to 9. This 4 adds up to with 1 to add up to 5, which means this can't be 1, so this is 3, which makes that 1. This can't be 1 anymore. This can no longer be 4 and 7, so now this is 3 and 8. This can't be 5, so this must be 6, which makes that a 1 to add up to 7. This can't be 3 because of that 3, therefore this must be 8, which makes this a 3. These two digits, well, this can't be an 8 anymore, so this must be 7, which makes that an 8. And that leaves this to be a 7. So this cannot be 7 or 6, so it must be 5. This can't be 5 or 7, so it must be 6, which makes that a 7. Okay, this can no longer be a 6 because of that 6. These two can't be 7s, or cannot be 7s. This can't be a 6, so this is not a 6 and these are not 7s. Let's see, what else do we have? 6. Yeah, we already knew that. The 2. Anything that's the 2 can only be 5 away from 7, 8, or 9. So one of these is 7, 8, or 9, and obviously this can't be 7. The 9 can be, though, 5 away from 1 through 4. So this is 1, 3, or 4 is possible. And this can't be 4 specifically. What else do we know? We know 9 cannot be here, and 8 cannot be here. These two digits add up to 10, but it can't be 1, 9. It cannot be 3, 7. So it could only be 2 and 8, where this would have to be 2, and that's 8 because this doesn't add up. 2 can never be in a 13 cage with 2 digits only, 2 cells. And this could be 4 or 6. Okay. 3 is one of these 2 cells here because of normal Sudoku rules, right? This can't be 3, this can't be 3. That eliminates these from being 3, therefore 3 must be one of these. So if this is 3, it could be 2 and 7 with it. So this could be 3, 2, 7, or it's 3, 4, 5. So that could be 3, 4, 5 there. And this has to add up to 13. So with 4 is 9, with 6 is 7, with 8 is 5. We know this can never have a 5. So that's 3 digits adding up to 19 without a 5. It could be 2, 8, 9. Oh, we know this is 8. So this cannot contain 8 because there's no repeats on run bands. So this could be 2, 8, 9. It could be 3, 7, 9. Or it could be 4, 6, 9 or 4, 7, 8. But if it's 4, 6, 9, actually that's possible. So it could be 4, 6, 9. Which would mean this is 4 or 9, this is 6 or 9, and this is 4, 6 or 9. Or 4, 7, 8. This can't be 8. This would have to be 4, 8. This could have to be 7, and this would be 4, 8. And again, this could be 2, 3, 7, 2, 4, 6. So this would be 2 or 6, and this would be... Oh, but it can never... Well, it could be 2, 4. So that would be 2, that would be 6, and that would be 4, right? And therefore, this can never be 6, right? Because if this is 6, this can only be with 2 and 4. That adds to 12. But then 4 would have to be here, which is impossible. So 6 can never be there. This can't be 5, so this can't be 8. This 4 eliminates that 4, so this can't be 9 then. Here we have 3 digits adding up to 19 also. So it could be, again, 2, 8, 9. It could be, it cannot be 3, 7, 9 because that's 3 is there. It could be, cannot be 4, 6, 9 because the 6 is here. It could be 4, 7, 8 though. So 4, 7, and 8 works. And this can't be 8. This can't be 4 either. So this would be 7 with 4, 8, 4, 8. Or it could be 5, 6, and 8. But the 6 is not possible, so the 5 cannot be here. Okay. This can't be 8 anymore, which means this can't be 5. There's no 5 here. Okay, let's say where is the 5 in row 7, right? It can't be here because of this 3, 5 pair. It can't be here because of the way it works out. If there's a 5 here, it has to be with 3 and 4, and 3 can only be here, so that can't be 5. Can't be here because of this 5. And it cannot be here because 5, 6, and 8 doesn't work because of that 6. And this 5 cannot no longer be there because 8 can't be here. Therefore, the 5 has to be here. So this is 5, which makes that 2. This can no longer be 2 and 9, so this has to be 3 and 8, which eliminates 5 and 8 as possibilities. So this can't be 5, this can't be 8. Where is the 2 in box 9? The only place it can be now is this 19 cage. So this must be 2, 8, and 9 here, which means 2 cannot be here. 9 can't be here, so this must be 7, which means this can't be 7. This must be 6, 8, and 9, which forces this to be a 7, which makes that 9, which makes that 4. So this can no longer be 9 and 4. This has to be 6 and 7 then. And 3 can no longer be here either. Therefore, this can't be 4 and this can't be 4. Therefore, this is 3. This can't be 3 or 4. So we have a 2, 8, and a 9 in row 7. Now this 3 can be with 2 and 7 or 4 and 5. So this is 5 or 7. This 6 or 8 can only be with 5 or 7. So that means that this has to be a 5, 7 pair in row 8, which eliminates 5 and 7 from the rest of the row. In addition to the 8 not being in the rest of the row, this can't be 8, this can't be 7, so now this is 6, which means this can't be 6, so this now must be 7. This can't be 6 or 7, so it must be 2 and 9 as a possibility. This cannot, we have a 5, 7, 5, 7 pair again in box 8, so the 5 and 7 cannot be in the rest of the box. And for this to be a set of 3 digits that add up to 19, the only possibilities now are 2, 8, and 9. Right? Because if you tried 4 and 6, the problem is 4 can't be either of these, and 6 can't be either of these. Therefore, 4 and 6 would both have to be here. And 3 doesn't work because of 3, 7, 9 is no longer have as a 3. And the 5 can't ever be here. So this has to be 2, 8, and 9, which forces this to be 4, which makes that 6 to add up to 10. So therefore, this must be 7 to add up to 13 with the 6, and this must be 5 to add up with 3 and 4 to add up to 12. So this cannot have a 3. It cannot have a 4. Therefore, what's the only one that can be next to a 9? It's only 1. So we know the 1 is here. This can't be 1. This can't be 1. Neither of these can be 1. Where's the 1 in box 5? It has to be here. This can no longer be 9. We know it has, this Renban has a 6, 8, and a 9. Therefore, the only set that can work on this Renban is 5, 6, 7, 8, 9. So therefore, we need a 5 and a 7. So this has to be 5, and that has to be 7, because this can't be 7. Therefore, this can't be 7 anymore. This cannot be 7 anymore. So we know this is 8 or 9 next to the 2, and 1 next to the 9. Five cannot be here, therefore one of these must be 5. And since 5 can only be next to 4 on a Renban, one of these has to be 4, which means this can't be 4, which means this has to be 1, which makes this 3, which makes that 1. That's 3 in the corner. We celebrate. This can no longer be the 1, therefore this must be the 1, and that must be next to a German whisper, adjacent to a 9 on the German whisper line. So this must be 9, which makes this 2, which makes that an 8. This can no longer be 8 or 9, so it must be a 6, which forces this to be 9, and that forces this to be 8. So 2 and 1 can no longer be here, so therefore this must be a 5, which makes this a 3. 5 is next to a 4 on a Renban, and 3 then has to be next to a 2 on a Renban. That leaves in this column only a 5. So this is 5. What are the possible sums on this region sum line? Actually, let's finish this off. This can't be a 4, and we need a 4 and 6 in these two cells. This can't be a 4, so this is a 6. This can't be a 6, so this is a 4. This has to be 3 and 6 in the rest of column 6. So therefore, this can't be a 6, which makes that a 3, which makes that a 6. This can no longer be 3, so it must be 5, which makes that a 3. These digits must be the same as these digits, because these 3 digits add up to what these 3 digits add up to, and these are both 1 and 3, and these are 1 and 3, so this must be a 9, which makes this an 8, so this can't be 8. Therefore, where's the 8 in box 9? It has to be specifically that one. This adds up to either 6 or 13. Right? 1, 3, and 9 add up to 13. But if that adds up to 13, these 3 must add up to 13, and that's not possible because 1 and 2 and 8 is the most, and that only adds up to 11. So this must be 1, 2, and 3. This must be 1, 2, or 3, which makes this 1, 2, or 3, so that's 9, which makes that 9, that 2. This is a 9, this is a 2. And now we just do Sudoku. So this must be a 3, because of what the possibilities are, and this must be a 9. This can't be 3, so this is 8. We have a 2 and a 5 here. That can't be 2, so this is 5, which makes that 2. We have a 4 and a 7 here. That can't be 7, so this is 4, which makes that 7. And we have a 8 and a 9 here. That can't be 9, so this is 8, and therefore that must be 9. And I hope that made sense. Yeah, that's just the way I went through it. What is this actually? The integral of x squared dx is 1/3 x cubed, and it's from -4 to 8. So you have 8 to the 3rd power. That's 2 to the 9th, essentially, which was, I believe, 512. Right? 8 times 8 is 64. 64 times 8 is 512. 4, you have -4 to the 3rd power, but you subtract it, so therefore that becomes a positive. So you have 512 plus 4 cubed. 4 squared is 16, plus times 4 is 64. So you have 512 plus 64. 512 plus 64 is 576. And then you divide by 3 because you have 1/3 x cubed to get the integral. So that's 576 divided by 3, which would be, you have 5 divided by 3 is 127, so that's 190, and then it's 6, so it's 192. So then all of these should add up to 192 if Evan did this correctly, which I trust he did. So you have 11 plus 15, 26, plus 9. So it's 26 plus 9 is 35. Plus 20 is 55. Plus 18, which is 73. Plus 12 is 85. Plus 14. Actually, this is just all 45. So whatever I had here. Okay, so this was, again, 11. This was 35. This is 20, so 55. Plus 18 is 73. Plus 45. 45 plus 73 is 118. We have 11 here. So again, 45 plus 73 is 118. Plus 11 is 129. Plus 26 is 155 plus 26 would be 181, and then plus 11 is 192. Yep. And so the numbers in the cages, which is the value beneath the curve, is 192, which fits this integral. Very cool. Very cool, Evan. Nice job. And I hope you enjoyed this episode of Learn How to Sudoku. And I'll see you next time on Frank Puzzles. Take care.